Well, in this video, I'd like to take a little look at level curves for a function of two variables. A picture on the screen is a elliptic paraboloid and some of its level curves. Here are the two animations that I'm going to look at. One of them for what was pictured on the cover screen, the elliptic paraboloid, and then over here we got a hyperbolic paraboloid. Both of them with level curves being animated. Level curve is actually for like z, a function of x and y, the surface that would be the graph of that function is going to have level curves corresponding to the curves of intersection of the surface with the plane z equal to a constant, which is going to be a horizontal plane, horizontal relative to the xy coordinate plane. And these curves of intersection of the plane and the surface are called level curves. Focusing first on the elliptic paraboloid, whose cross sections are ellipses, so the level curves are ellipses. Traces vertically would be parabolas, which is where it gets its name, elliptic paraboloid. The picture you're looking at is showing the level curves for intersections with z equal to 0, 2, 4 by 2s up to 36. This is the actual equation, z equals 36 minus 4x squared minus 9y squared of the elliptic paraboloid. Now, in the next slide here, I've got the same picture, except this one is a little MP4 video within the video. If I click there, you can see this MP4 animate the plane. The advantage here is that I can actually click in the slider and just look at one of the level curves, this one corresponding to z equal to 6, so that the equation of that level curve would be found by putting 6 in here for the constant, and then you wind up getting an ellipse whose equation would be 4x squared plus 9y squared equals 30. Subtracting the c equal to 36 from the 36. If I click up here, we can look at another one. This corresponds to z equals 20. So it would be 36 minus 4x squared minus 9y squared equals 20. Or 4x squared plus 9y squared equals 36 minus 20, 16. And you could click out here, and there's another one. There's your level curve for that, and then take a look at all of them that I pictured again one more time. And then here's my animation for level curves for a hyperbolic paraboloid. Its equation is z equals 16x squared minus 9y squared. We're going to look at level curves corresponding to z equal to negative 1500, negative 1400 up by hundreds to positive 1500. You kind of notice here that the level curves are hyperbolas, and that what happens is down here the hyperbola is opening to the left and right, opening in the y direction, and then up here it's opening in the x direction. I guess I want to say left and right again, but it's, you're opening up here in the x direction, opening down here in the y direction. And we can take a look at that. Well, actually, before we look at that, the hyperbolic paraboloid, it gets its paraboloid name also from vertical cross sections, and they're called traces. And this here, we're looking at the hyperbolic paraboloid, so from down below, and looking at, in green, the plane x equal to 0. Again, the picture's tilted, and it's making an intersection with the hyperbolic paraboloid along this red curve here, which is a portion of a parabola. Now back to the level curve. So here we're looking at my hyperbolic paraboloid again. 16x squared minus 9y squared equals to a constant would be the equation of the level curve, where that constant is whatever z equals in the equation of the plane. So here we got the plane down at z equal to negative 1500. So the actual hyperbola, here's one branch, here's the other one, here's opening in the y direction, would be 16x squared minus 9y squared equals negative 1500. Of course, that negative value for the constant actually turns this into a y squared minus x squared equal to a positive number type of hyperbola. And that y squared minus x squared type opens in the y direction, and down here it's opening in the, here's the y direction here and here, it's opening in the y direction. And if I click in here, we got a plane z equal to negative 900, so this constant is still negative. You still wind up with a y squared minus x squared type opening in the y direction. But if we click up here, you're up above z equal to 0 to z equal to 300 here, so you put 300 in for the constant. You got the equation of this hyperbola. It's opening with one branch looking like that, and the other one looking like that, opening in the x direction. And if we go up a little higher, there's another opening in the x direction. This one's at z equal to 900, so you'll be putting 900 in for that constant to get the actual equation of the hyperbola. It would be the intersection of this red plane and my hyperbolic paraboloid. And if we maybe click one more time here, there's another one. I'll let you look at them all one more time here. Kind of cute. And now we'll conclude here with this is a contour plot corresponding to the level curves of the hyperbolic paraboloid they've been looking at. You can see all these curves here, like this one goes with that one, hyperbola. This one goes with that one, another hyperbola. And that one goes with that one. And each curve is sort of representing a particular level, particular value for z equal to some constant, and that horizontal plane intersecting the hyperbolic paraboloid to form the level curve. Well, I hope you all stay safe out there. It's still a little dangerous. I'm going to call the end of this